140, whereby we are looking at information under 6.3, and we are told that you can describe vectors using I and J notation. And to explain this, we are already told that a unit vector is a vector of length 1. The unit vectors along the Cartesian axis are usually denoted by I and J. So you will find the Cartesian plane. This is the origin. Unit vector, this one along the x-axis, always denoted as I. This one unit along the y-axis, always denoted as J. Of course, we have the negative side and we have the negative side of both sides. And this is vectors in 2 dimensions. And for now, we are going to understand vectors in 2 dimensions. Later on, we might include the K, which will beef up our information as far as vectors is concerned. But for now, let us talk about vectors in 2 dimensions. And you can write any vector you can write any 2-dimension vectors in the form of AI plus BJ, where A is the coefficient of the vectors along the x-axis and B is the coefficient of vectors along the y-axis. And for example, if you talk about if you have a diagram or vector arrangement of this nature, from whereby this is 5i and this is 2j, then we can talk of, and this is point A, point B, point C, then we can conclude and say that vector AC is given by AB plus BC. This, in short, is that vector AC is 5i plus 2j. If you look at example 6, we are told that draw a diagram to represent a vector of minus 3i plus j, minus 3i plus j, to draw. If we talk about this being a starting point, you can see our vector along the x-axis is negative. That means we'll be moving to the left, negative side. If it was positive, then we'll be moving to the right. So to the left, 3 steps, then we can talk about 1, 2, 3. And that could be our minus 3i. From this particular point, then we walk along the y-axis. How many steps? 1 step, which is positive, and this is our j. So if this is point O and this is point A, then that is our vector OA, which is minus 3i plus j. All right?